Hi everyone. This lesson is going to be about identifying the critical path and the float time for various activities. So if you haven't watched the previous video, I recommend you do. The previous video started with this activity network. I redrew it and then performed a forward and a backward scan. As a process of doing the forward and backward scan, I identify the earliest start time and the latest start time for each of the various activities here. And the details of that are in the last video. Now let's take a look at these vertices. These vertices have got two different numbers in them. Some vertices have the same number for earliest start and latest start time. Some have different numbers. For instance, this vertex here has a 2 and an 8, clearly different. This one here has both 15, the same. The critical path are the edges that join vertices that have the same value for EST and LST. Now, we always have to have 0 and 0 at the start. Which of these edges leads to a vertex that has the same numbers? Well, edge A does, 7 and 7. Then edge D leads to 15, 15. Remember, I can't go against the direction of the arrows. Edge G leads down here to the one which is 20, 20, and then H leads across here. I have just highlighted the critical path. That is the jobs that must not be delayed. If we have any delays whatsoever with job A, D, G, or H, the entire project is put back. So the critical path is really quite a simple thing to work out. And I just list the jobs. The critical path is job A, then it was D, then it was G, then it was H. That's the critical path. I'll highlight that. Oops, that's not highlighting. Try again. Let's highlight that. Now, some of these jobs, some of the activities in this network were not on the critical path. There are 4 of them. And for those jobs, there's a little bit of leeway, and we call it float time. Let's look at E, for instance. The earliest we could start job E is after 2 minutes, and job E must be completed by 15 minutes, so that G is not delayed. So I'm looking at the number at this is just for E. I'm looking at the number there and the number there. So 15 take 2 is 13. I've got a 13-minute window that I have to fit job E into, and job E is only 7 minutes. How much float time is there for job E? Well, it's 13 take 7. Let's write this down. So for job E, the float time, as it's called, sometimes called slack time, well, looking at the edges, the ends of this, that's a latest start time, and that's an earliest start time. So that's the latest start time at the finish, and that's the earliest start time at the beginning. What were those numbers? 15 take 2. And that gives me the little time window in which I have to get job E completed. So 15 take 2 is where I got 13 from. Job E, of course, as we can see, the duration of job E was 7. So I end up with 13 take 7, or 6. The float time for job E is 6. Now, we'd do the same thing with the other activities that are not on the critical path. So if I look here at F, I have 20, take away 6, and the activity took 9. So for F, the float time is 20 take 6, and job F itself took 9 minutes. 20 take 6, that's 14, take away 9. There's a 5-minute float time for F. For job C, I have 11, take nothing, and job C is 6. So 11, take nothing. Job C was 6. That comes to 5. 5 minutes of float time. And job B, have to do job B, have to do all of them. That's 8, take 0, with an activity duration of 2. So for job B, 8 takes 0 and the activity took 2, that's 6. Now we can see here that some of them have more float time than others. And here's the other thing, you can't give the maximum amount of float time to all of the jobs, otherwise you will end up pushing things out a little bit. If I gave 6 minutes of float time to job B, so if I let job B sit idle for 6 minutes and then the 2 minutes of the job, we get to this point 8 minutes. That is the latest starting time for job E. Job E then has to be done straight away. If I give the float time to B, E doesn't get any. On the other hand, if job B is done on time, straight away, so it's 2 minutes to that point, then job E gets all of the float time. So because B and E are joined together like this, then B and E, they can't both get this float time. One of them can get all of it, the other one could get all of it, or they could get a little bit each, but they couldn't both get the maximum float time. The same sort of thing applies with C and F. They couldn't both get maximum float time. So these float times that we're talking about are for individual jobs. But if you wanted to then allocate that, you'd have to be more careful with the way you worked out through the network. All right, that's enough for now. Thanks for watching.